So here we're going to be working out the coefficients. So previously we worked out the term, and now we want to work out the coefficient. The only difference here, it's a little bit more difficult to work out what k equals to, and I'll show you that. But once we've worked out what k equals to, we substitute it again into the general term, and then we just work it out. So let's have a look. The best way here is just have a look at the questions, all right? We want to find the coefficient of x to the power of 10 in the expansion of 3 plus 2x squared power of 12. So this tells me that I want to find the coefficient of x to the power of 10, which means I need to work out the general term for this and find out what k equals to for x to be to the power of 10. So the first thing is I need to write out the general term. So I know that tk plus 1 is going to equal to, the index here is 12, so 12ck, 3 to the power of 12 minus k, and 2x squared to the power of k. And I'm just going to simplify that a little. So this becomes 3 to the power of 12 minus k. This is 2 to the power of k. This is x squared to the power of k, which is the same as x to the power of 2k. Now this is what I want to look at here. This x to the power of 2k, because this is how I'm going to work out what k equals to for x to equal to the power of 10. So I know that I want to find the coefficient when x equals the power of 10. So that means I want when 2k equals to 10, because that's the only x there and that has to equal to that. Divide both sides by 2. That means therefore k has to equal to 5 for x to be the power of 10. And now once I work this out, I just need to substitute it into this part here. Yeah, so just the numbers to work out the coefficient. So that'll be the sixth term in this case, 12c5, 3 to the power of 12 minus 5, 2 to the power of 5, and just put that into your calculator, and you should get this number here as your coefficient. Now, so let's have a look at what we did. The first step we need to do is write out the general term, and then we simplify it until we have x by itself, just one x, and then we want to make the index of that x equal to that. That's what we've done here, 2k equals to 10. Once we work out what k equals to, we just substitute it back into the general term. But because it's looking for only the coefficient, make sure you only work out the number of it, right? So we're not writing this x to the power of 10. Yeah, do you get what I mean? We're only working out the coefficient. That's why we don't need to add that part into it. So I want to find the coefficient of x power of 3 in the expansion of 2x minus 5 on x squared to the power of 9. Now I can see that we have two x's here, which means that we're going to have to, when we simplify, bring those x's together because we need only one x to make us able to equate the indices, right? So general term first. Here we have to the power of 9, so we know that's going to be 9ck. So it'll be 2x to the power of 9 minus k. And here, negative 5 on x squared to the power of k. And we need to simplify. So I'm just going to break those two up. So this becomes 2 to the power of 9 minus k. This is x to the power of 9 minus k. I'm going to break those up as well. So negative 5 power of k. And this is x squared, but because it's a denominator, it would be x to the power of negative 2 times k there. And now, because these two terms are the same, that means I can add together the indices, right? So here it's going to be 9 minus k, and then subtract another 2k. So you get 9 minus 3k there. And remember, this is what we're focusing on to work out what k equals to, because we want to equate the indices. So I want to make 9 minus 3k equals to that 3 there. So here I'll just move that 3 over there, but move that 3k over there. So we have that 9 minus 3 is going to be 6, and that equals to 3k. So in this case, divide both sides by 3, and you get k equals to 2. So that is your difficult part done. We've worked out what k equals to, and now all we need to do to work out the coefficient, that's right, just substitute it back into this portion. Yeah, because we're just looking for the coefficient. So substitute it in. We have 9c2, then 2 to the power of 9 minus 2, negative 5, power of 2, pop into your calculator, and you should get 115,200 as your coefficient, okay? So you can see that it does look complicated, I'll agree with that, but it's not that bad. It really is just general term, getting just one x and then equating the indices of this with that. Finally, working out what k equals to, and then it's just an easy process of subbing it back into there to work out your coefficient. So we want to find the coefficient here of p squared and q cubed in the expansion of 3p minus 2 cubed power of 5. Now you can see this is a little bit different, isn't it? Because instead of having just x cubed or x to the power of 10, we have p squared and q to the power of 3. So there's actually two things that we're working with. So how do we do that? Well, it's actually really simple. We only just choose one or the other. So I'll show you what I mean. So we start off with a general term again. That's power of 5. So we have 5ck, 3p to the power of 5 minus k, and negative 2 cubed to the power of k. I always make sure that we are going to separate the number and the p there. So 3 to the power of 5 minus k, that's p to the power of 5 minus k. Minus 2 to the power of k, q to the power of k. Now, this is what I mean by choosing one or the other. So either you can go, I'm going to look at p and equate that index with the 2 in p squared. Or you can say, I'm going to look at q and equate that with the index of q cubed. So you choose one or the other. That's all you need to do. So we're going to choose p in this case. So equate these coefficients. 5 minus k equals to 2. So that means k has to equal to 3. We've worked out k. Now we just need to substitute that into these numbers here. So 5c3, 3 to the power of 5 minus 3, minus 2 to the power of 3, and that equals to negative 720 when you put into your calculator. Now you can see that if we chose a q instead, so q to the power of k, q to the power of 3, and equate the coefficients, you would also get k equals to 3. So just note, if you have more than one different thing here, so if you have 2 or 3 or 4, whatever it is, as long as you have, just choose one and find k, that's it. Just stick to one and that's all you need to do.